Our project aimed to create a tool that is useful for scientists trying to visualize subsurface geology on Mars. Martian geology is not fully understood, and by finding out more, we may find signs of life or find locations for future Mars missions. The Mars rover has many advanced tools, but some are more time-consuming than others, so finding the perfect spot for experiments is very important, and having a good hypothesis for geological sublayers aids in this task. Currently, many geologists use 2D diagrams to accomplish this, such as annotated pictures or block diagrams. In our project, we created a tool that gives geologists a sense of scale in 3D while sketching their hypotheses and visualizing sublayers. The tool we made has two main functions, sketching and visualizing. Sketching is the process of placing new subsurface layers according to the scientist's hypothesis. To do this, we use a method of placing cross-sections on the terrain, then placing points on the cross-sections. The points are later connected to form the sublayers. To draw a cross-section, users choose 2 points on the ground. A wall will appear, signifying the cross-sections. If 2 cross-sections are placed, the area around the cross-sections will become transparent, while the area between the cross-sections will become opaque. This gives the user a clearer view while choosing where to draw the sublayers. To draw a sublayer, first, points are placed on a cross-section. After drawing points on 2 or more cross-sections, the points can be connected to form the sublayers. This is accomplished by selecting 3 points, which become a triangular mesh. After drawing some triangles, the sublayers can be selected, which can then be deleted or have their properties changed. The second geology task we aimed to aid in was visualizing the geological sublayers in a meaningful way. After drawing many layers, the subsurfaces can begin to look messy and complicated. We thought that transparency was the key to giving a sense of the relative depths of the surface layers. The user is free to move around the environment, and when they wish, they can choose an area to inspect. It will turn opaque, and the rest of the environment will remain partially transparent. The sublayers underneath the selected area will also become opaque. After selecting the area, the user can then use the scroll wheel to increase or decrease the size of the selected area, or click anywhere to choose a new area to view. There are a number of ideas we had which were only partially implemented, and many unanswered questions remain. Firstly, we would have liked the user to be allowed to draw arbitrary shapes on the cross-sections, rather than point by point, and for the layers to be connected between cross-sections automatically, rather than the need for individual triangle selection. If the shape of the sublayers becomes too complicated, drawing point by point and selecting triangles can become too difficult. Secondly, the ideal tool would allow more user control over features such as the level of transparency or the shape of the visualizing area. Currently, these are fixed. Transparency and opacity are a fixed value, and the visualization area is always a square.